Here in this problem, we're going to find the relative extrema using both the first and second derivative tests. So notice they're asking for the actual extrema value and not only where it happens. So for the first derivative test, I'm going to take the first derivative, and I get 8 minus 6x, and I see that f prime of x equals 0 when x equals 4/3. So that's my critical value. So now I can do a sign chart to compare my first derivative to my graph. Now this part is not really required, but it's helpful for visualizing what's going on. So if I pick a number less than 4/3 to plug into my derivative, I get a positive number, which means my function's increasing. If I pick a number greater than 4/3 to plug in, I get a negative number, so it's decreasing. So we can see that 4/3 is where relative max occurs. So now what I'm going to do is take that 4/3 and plug it into my original function to see what my actual maximum value is. So now I have 3/3 plus 32/3 minus 16/3, so that is 19/3. So now to summarize what I just found, f has a relative max of 19/3 at x equals 4/3. Now let's justify our reasoning. Because f prime of 4/3 equals 0, that means it's a critical value, and f prime of x changes signs from positive to negative at this value. So that is full explanation with justification of reasoning. So now let's do the same idea, but using the second derivative test. So first thing we have to know for the second derivative test is where our first derivative is equal to 0. So we already know f prime of 4/3 equals 0. So since that's a critical value, now I need to check the second derivative at that value to see if it's positive or negative. So f double prime of x is just -6. So f double prime of 4/3 is -6, which is less than 0. So since my second derivative is less than 0, that means it's concave down, so therefore that must be a max at that critical value. So by the second derivative test, f has a relative max of 19/3 at x equals 4/3 because f prime of 4/3 equals 0 and f double prime of 4/3 is less than 0. So that is the second derivative test with full justification for your reasoning.